Hi, welcome to Calc with Cola. So we're going to do the AB BC number 4 question on the exam. If I had to pick my favorite question, this would have been my favorite question. I just love this question. Okay, so let's see what we got going on here. They give us a graph of F. They tell us that this region had an area of 12, and then they just describe what's going on. And this is important, it becomes linear when we get over here, okay? So letter A, they give us a function g, so we see an x, an integral, and a t. I'm thinking it has something to do with FTC. They want us to find the following 3 values. So to me, that probably means this is 3 points. So what I'm gonna do is I'm gonna set up the 3 integrals. So if they want us to find g of -6, so we have a formula for g, I'm gonna put it in a box. So then g of -6 is gonna be the integral from 0 to -6 of f of t dt. Okay, that is not in the proper form. So I am going to negate it and flip it. So this is saying they want us to find the area from -6 to 0. Well, they gave it to us. It's 12, but there's a negative in front because we had to negate it and flip it. So it's actually going to be equal to -12. Okay? I'll do them all in different colors. So now let's find g of 4. G of 4 is going to be the integral from 0 to 4 of f of t dt. Well, come on up. We need to find the area from 0 to 4. Oh, that's a nice little triangle. So then that area is going to be 4, 1/2 base times height. You don't need to show that you're calculating the area of a triangle on your paper. And then lastly, g of 6 is the area from 0 to 6. So we're probably going to have to calculate this little guy right here. He's hanging right here. So that's going to be -1. So now from 0 to 6, when you add it up, the area is going to be 3. Okay? Great. Letter B, what do we got here? For the function g defined in part A, find all values of x on the interval at which the graph has a critical point. So when g has a critical point. So this is how you should have, your thought process should have been. We have a critical point when the derivative is equal to 0. So I'm going to say when g prime is equal to 0. Well, come on up here. And you might be saying, well, where do you get g prime from? Right here. If I want to derive an integral, second FTC, all we're going to do is we're going to circle the variable and we're going to replace t with that variable. So then g prime of x is equal to f of x. So that should have been written down somewhere on your paper, probably to get full credit for this question. So not only is this the graph of f / it's the graph of g prime. So they want to know when this graph has a critical point. Remember, a critical point is when g prime is equal to 0. Well, look at this. Isn't the only spot where this graph equals 0 at x equals 4? So that's what I'm going to write. G prime equals 0 at x equals 4 because g prime of x equals f of x equals 0. Okay, we equal 0 at that spot. That's my reason. And then letter C. Letter C I thought was the trickiest out of the 3. So look at this. They now give us h. They love giving us a whole new function. And they want us to find h of 6, h prime of 6, and h double prime of 6. So I think the hardest one was to find h double prime of 6, but I'm going to explain it. So if we want to find h of 6, I'm going to start by plugging it into the formula. Okay, when you integrate the derivative, you get back to the function. So when I integrate this, this is going to become f of t, because you're integrating the f prime, you're going to get back to f, from -6 to 6. So now that's going to be f of 6 minus f of -6. Well, that's the graph of f. So to find f of 6 and f of -6, we're just going to look at the graph. F of 6 is -1, f of -6 is 0.5. So it's going to be -1 minus 0.5, which you could have left it like that, of course, but you also could have written it as -1.5. Up to you. All right, next. Here we go. They want us to do the fundamental theorem again. They want us to derive this blue box. So we're going to replace t with x, and I'm going to say h prime of x is equal to f prime of x. So that's interesting. So if they want me to find h prime of 6, we need to find f prime of 6. If this is the graph of f, F prime means slope, okay? So they wanted you to find the slope of this straight line right here. You could have done change in y over change in x, or just rise over run. If we're going down 2 over 4, so the slope's going to be negative 1/2. So then I'm going to say h prime of 6 is negative 1/2. And now this is where it got interesting. So they want us to find h double prime of 6. I'm going to do that one up here so I can kind of explain it. H double prime of 6. So, this guy's, so h prime would be the derivative graph of this. So you have to think, if f is a straight line, then its derivative is a constant, okay? Like if I had you guys derive this equation of a line right here, okay? I gave you a function and I said, this is the equation of the line, which it is, and I asked you to do the first derivative, it'd be negative 1/2. If I asked you to derive it again, you would get 0. You're gonna use that same logic here. Because the first derivative is a constant, then the second derivative, the derivative of a constant, is 0. I thought that was the hardest part of the question, but it is my favorite question.